Hello everyone. Today our topic is difference between row number, rank, dense rank, and percent rank. So we'll see in detail how these functions work in PySpark. So first we'll discuss about the row number, row underscore number. So all these functions, it is similar to SQL. So same way it will work, same functionality, and the result will be same. So only way of writing the code in PySpark is different. So first we'll see about row underscore number. So the row underscore number function in PySpark is a window function that assigns a unique sequential number, it starting from 0. And it is assigned to each row within the defined partition. So that means row number, whenever you apply to data frame on particular column as partition, so that divides into number of partitions, and each partition, it assigns the value that is starting from 1 and to each row of that particular window. So it is commonly used for ranking data, selecting the top n records within a group. So we'll see when to use row underscore number. So this function mainly in real time we'll use to remove the duplicates. So whenever you move data from source to branch, so in branch layer, it is allowed to have duplicate records. But whenever you move from data from bronze to silver layer, so always you need to filter the data. That means always we need to remove the duplicate records. So there we will use this row underscore number function to remove the duplicates and keep only latest records, unique records. So first function is to remove the duplicates and to keep only latest records and deduplicate based on composite keys. So that means to remove the duplicate records based on composite means multiple primary keys and to implement SCD logic. So first we'll see the difference between all these four functions. So first, if you see row underscore number, it assigns a unique sequential number to each row. So whenever time happened, so that means time is within the partition. If the value, if the same value is coming, that means it repeating twice or more than twice, then still it will assign different consecutive numbers. That is 1, 2, 3, 4 like that. So here you don't see any difference. So whenever you have same numbers. Next, if you come to rank, it assigns the same rank to tied values, but leaves a gap in the sequence. So that means whenever you get tied values with the same rank, then what it does is, see the ranks are skipped. So that means first is unique value, and suppose the second and third you got same values. So same values means you will get same rank. So here rank, what it does is it will give you 2, 2. But whenever it gives for next unique record, it will give 4. So it won't give 3. So that it telling. So subsequent ranks are skipped. But if you see here, so even though here 2 and 3 values are repeating, that means a duplicate, but still it will give 2, 3, not same rank. And if you come to dense rank, it assigns the same rank to tied values, but it does not leave gaps. So like here, see here it assigned the same value, but for next value, it took 4, not consecutive number. So it skipped that 3. But in case of dense rank, it will give consecutive numbers. So consecutive numbers means first one is unique and second and third are duplicate. So it assigned same number, that means same rank. And for next unique number, it given consecutive number. So that means after 2, 3 comes. But here 3 it will skip and 4. Suppose if you have 3 duplicate numbers here, that means 1, 2, 2, then next it will come 5. Okay, so it is like that. But here you will get 1, 2, 2, 2, 3 you will get. So next percent underscore rank. So it returns a normalized rank between 0 and 1. So it gives the ranking between 0 and 1. So based on row position and within each partition, and it will give you decimal format. So since value between 0 and 1, so 0 and 1, first value will be 0 and the last value will be 1, and in between it will give you decimal format in the percentile form. So this is on high level, the difference between. So these things we'll see with example how it looks. So first I'm importing required functions here. So first I want to import PySpark.sql. From PySpark.sql, import window. So first we want to import the window function. So next PySpark.sql dot functions. So here we need to import all these aggregate functions. So row number, sorry, not aggregate, window functions. So row number, rank, dense rank, percent rank. And to define the schema, we want to import from types. We want to import these types here. So here what I'm doing, so this is my sample data frame. So this is my data. And to explain mainly rank, percentile rank. So I added a few null values here and some duplicate values here. So that easy to understand how the function will work. So by using spark.create data frame and this sample data I'm passing here, and here I'm passing schema with the help of structured schema. So first struct type, and inside that I have 3 columns. So since it is 3 columns, we need to define 3 fields, that is struct fields. So this is one struct field. So here we are defining first column. So that is employee underscore name. Next for this data type, we need to mention string type and either true or false. That means whether nulls are allowed or not. So next struct field is, that is next column is this one. So that is a department and data type is string and it is true. And similar way, struct field, column name is salary and data type is integer and I given true. So by using this, I created this data frame. So here, if you observe, we have some null values and at the same time, suppose if you see this particular window, that means if you do partition by on this department, so this will become one group. So here one sales is there and here one sales. So here one is there and here one is there. So in this, if you see 3000 here 4100, so here 4100 is there, here 4100 is there, that means a duplicate. So here 4600 is there, here 4600 is there. So two duplicate values in first window sales. And if you come to finance, so here 3000, here 3300, and these two are duplicate 3900, 3900, and here one null is there. And if you come to marketing, here we don't have any duplicate. And for admin, we have one record that is 5680, and this is I given purposely to explain this percentile rank. So now after creating data frame, what I'm doing, so I want to apply all these functions together. And I want to show the how ranking displays for each function. So here to display the rank on top of this data frame, that means currently we have 3 columns. So here what I'm doing, I'm trying to add one more column here, that is rank column, to display the rank of each row within that window. So that is this one, add column with row number to data frame by partition. So for each partition, I want to assign the rank by using these functions. So By using these functions, I want to assign the number. So here orderBy class is mandatory in the window specification when you are using ranking window functions such as these functions. And here I will mention percentile rank also. So percentile rank also, it is mandatory to mention orderBy. Okay, so whenever you use window functions, so orderBy class is mandatory. And without orderBy, these functions cannot determine the order of rows within each partition and will result in error 1. For analytic and aggregate window functions, orderBy is optional unless the function's logic requires it. So that means whenever you use aggregate functions, group by and aggregate functions, so orderBy is optional. So here, first what I'm doing, if you see the SQL code, first I will show you the difference between SQL code, how it will be. What I will do, I will open one more notebook. There I have SQL code. First, I will show you the difference between SQL code and PySpark code. So then whoever comes from SQL background, it will be easy to understand how it differs between SQL and PySpark. So minor change will be there. Uh, okay, so this is the SQL. You'll write code for ranking. So what we'll write? Select star. So that means number of columns. And first we'll write our window function, row underscore number. And we will write space over. And inside over, we will write these two things. One is partition by and second is order by. Okay, so this is our SQL code. And same thing we'll see in PySpark how we'll write. So select star, row number, over. So here how we'll write is yeah. So in PySpark, we know that for adding any new column, we'll use with column. So this is our sample data frame dot with column. So if you use one with column, you will get add one row. So what is that? Sorry, one column. So what is that column name? Row underscore number. But here I want to show you total 4 window functions. So that is the reason I given 4 dot with columns here. So each with column, it will add you one column. So this particular with column will add you row underscore number, and second with column, it will add you rank, column name is rank, and third one is dense underscore rank, and fourth one is percent underscore rank. And each line of code, I used different window functions. So here I used row underscore number. So as we compare with SQL, so first of all, what we'll write? Row underscore number. So up to here, this is same. And in SQL, what we'll write? Space over. But here we have to dot. So row number dot over, and inside over. So whatever we are writing here, that is partition by order by. So that here we are defining one variable that we are passing here. So window.spec. See here, if you see for each, since it is common for all the window functions, so this portion, it is common for all the window functions. So I define to one particular variable, that is window underscore spec. So this particular variable, it is passed to each window function. So inside over. And here only difference is whatever this partition by, so it is defined in one, we can say one, we can say like library or similar kind of thing. So window dot partition by. So in SQL, what we'll do, we'll directly write partition by and space order by. So but here, so whatever we are writing this partition by and order by, so that window first we imported here. If you see here from PySpark.sql import window. So this window we are using here. So that library we are using here, window dot partition by, so department dot order by salary. So in SQL, so we don't have any in between dot. So partition by columns, then order by column. So in between we don't have dot, but in PySpark we'll get dot. So window dot partition by. So here you can pass multiple columns. And at the same time in order by also we can pass multiple columns. So this window spec I'm passing here for each window. So otherwise, if you say syntax is same. So here I passed row underscore number. So here I passed rank. So here I passed dense rank, and here I passed percent underscore rank. So if you see the result, how it display. So first it will go for group each group. So that means we given partition by on department. So first we'll see on department wise. If you see this particular department, so in this we have only one row. So that is admin department. So salary is 5680. And if you see relevant ranks, see all will get one. So first three window functions will get one. And only percent underscore rank will get 0. So percent underscore rank, how it works is, so as we discussed, these three, it will start from 1, 2, 3, 4 numerical numbers, it will start. But percent underscore rank, if you see here, so it is a window function that calculates the relative work, that means percentile of a row within each partition. So the values between 0 and 1. So values always will be 0 and 1. That is one point. And the first row in any partition always has percent rank of 0. This is one point. And one more is, if a partition has only one row, then the rank is 0. So that is this one. So since we have only one row, so the rank will be 0. And next, if you come to this finance, in finance department, so these are all the finance department. And here, first we have null, then we have 3000, 3300, 3900, 3900. And if you see here, so wherever null is there, percent underscore rank or any other window function, it treats null value as the lowest values. So, and it assigns them a rank of 0. In case of percent underscore rank, it assigns a rank of 0. But in other cases, it will assign rank of 1. So that is the reason, if you see, for row number, rank, dense rank, so wherever null is there, it assigning as the smallest value and it is rank 1. But in case of percent underscore rank, so whenever null is there, that it considered as the lowest value and rank will be 0. Why? Because in case of percent and underscore rank, values will be between 0 and 1, and our first rank will be always 0. So that is the reason it is 0. And next, if you see, this is 3000. So based on this number of values in window, it will assign this percentile 0.25. And at the same time, next 3300, this it is assigned 1 percentile value. And if you observe here, here two values are repeating. That means duplicate value. So wherever duplicate value, it will assign you same percentile. So that means here how it is assigning same rank. So similar way, it will assign same percentile. And if you see here, so one more point, order by is compulsory in percent underscore rank. So without specifying order by, so it won't work, this percent underscore rank. And whenever you have tie, so tie means duplicate records. So rows with the same value in the order by column receive same percent rank. So that is this one. So we are since values are same, so here we'll get same rank, and similar way we'll get same percentage. And this is about percent underscore rank. Next we'll see about row underscore number. As we discussed, whenever you have duplicate records, it won't consider, it will give you consecutive numbers. So it's starting with 1, 2, 3, 4, 5. So it will ignore duplicate, it will give consecutive numbers. But in case of rank, so this is first rank, and this is second rank, and this is third rank. But here we have same values. So after 3, it will give you 4, 4. Same rank, it will give you. So maybe here what I will do, I will add one more value so that it will be easy to understand. Finance. Why? Because after duplicates, we want to see what number it comes. So finance, what we are, it is repeating 3900. So what I'll give 4500. I will execute it again. So here, see here in finance, one more row got added. And if you see the rank, see here, whenever you added row, so these values, percentile values also got changed. But wherever duplicate is there, we are getting same percentage. And here we are getting 1. And mainly we are discussing here 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So it will give consecutive number. When it comes to rank, so here we have duplicate numbers 4, 4. As per rank, what it gives. So after duplication, whenever you get your next unique record, it won't give you consecutive number. So after 4, it will give you 6. Why it giving 6 here? Here 4 is there, and here it is repeating twice. So that means 4, 5, 6. Suppose if you have 3 duplicate records here, then here it will give you 7. So what I will do, I will add one more duplicate value here to show that one. So if I run this one, here you will see here, we are getting 7 here. So if you see in finance, so I added, so according to that new row, so this percentile is getting changed. Since I added 3 duplicate rows, so here percentile we are getting 3 common same percentile value. And if you come to rank, so earlier we have 2 duplicates, 4, 4, and next number it gave you 6. But here, since we have 3 duplicate records, so actually 4, 5, 6, so 7 it will come. So if you add one more duplicate value, So total 4 ranking will come, but here you will get 8. It works like this. And similar way, dense rank also 1, 2, 3, and duplicates are 4, 4, 4. So how many duplicates will come? Here it will come your next consecutive number. So even here, if we have 10 times it is repeating, 10 duplicates values are there, and your ranking will be 10 times it will be 4, and but still next unique number will be 5. Okay, so that's how it will work. And in percentile rank, the range will be between 0 and 1. So according to in your window, number of rows, this percentile will change. If you add one more row here, then this percentile will get changed. And similar way, if you come to marketing, so here we have only 2 rows and those 2 are so unique. So for all 3 cases, you will get 1, 2. And if you see here, starting value is 0 and ending is 1 because we don't have any additional rows or duplicate records. And if you come to sales, so first value is null. So all cases will get 1, 1. So, but here you will get 0. And here 3000 is there. So 1, 2, and 3503, and here 4. So all are unique values. So we are getting all are 1, 2, 3, 4 only. So here 0. So here 0.5 and this percentile. So I will show you one formula how it calculates. It totally depends on means this percentile underscore work. It will work totally based on this formula. So percent underscore rank. So what it does is, so rank minus 1 divided by total rows in partition minus 1. So based on this formula, it will give you this percentile values. Okay, so this we discussed, all the points we discussed. So next, add row number to the data frame without partition. So here what I'm doing, earlier Window.partitionBy I mentioned, partition column I mentioned. So here what I'm doing, I'm ignoring that partition. Now we'll see how it works. So if I run this one without partition, so it will give you result. At the same time, it will give you the warning also. So user warning. So window exception. So no partition defined for window operation. So moving all data to single partition, this can cause serious performance degradation. So it giving you warning. So your intention is to do without partition, so you can proceed. So, but from Spark side, it will give you the warning here. And how it works is, since I removed partition, so how it giving numbering. So how it giving numbering is, so first it pulling all nulls to the top. So first we are getting nulls and it giving you numbering 1, 2. So in case of row underscore number, see here, whether it is duplicates or duplicate null values, you won't bother, it will give you consecutive numbers. But in case of rank and dense rank, it giving same rank. And parallelly, we'll see about percent rank. So percent rank, we know that. So whenever null is there, we'll get 0. See here, this is null, we are getting 0, and this is null, we are getting 0. And so next it is 2000. See it first it assigning in a descending order, means ascending order from lowest value to highest value, because I given in order by, I'm not mentioned here ascending or descending, it took by default ascending order. So it giving lowest to highest value and it giving the ranking for. So in row number, we'll get 1, 2, 3, 4 continuously. How many rows are there? That many ranks will get. But in case of rank, we know that, see, this is unique number, but these 3 are duplicate records. So if you see here, 1, 1, here 2 ones it happened. In case of rank, what will come? 3 here. So because 1, 2, 3. So after 3, 4, 4 it is coming 3 times. So next value, how it comes? 4, 5, 6, 7. So 7 is coming. But in case of dense rank, after 3, next consecutive number is 4. Okay, so next, this is unique number. You will get same, means that next consecutive number will get 3, 9. So here we have duplicate record. So here after 8, 9, 10, 11. So here you will get consecutive number. But here after 8, 3 nines will get. And next number, how it will be? This is 9, 10, 11, 12 you will get. But here after 5, what is there? 3, 6. But here what you will get? Next consecutive number, that is 7. And next, if you go for this is duplicate values. So here we'll get consecutive 12, 13. But here, here we have 3 nines. So 9, 10, 11, 12. So 12, it repeats 2 times. And what is next value? So here 12, 13, 14 you'll get. But here after 6, what is there? 7 it repeating twice. And after 7, we are getting 8. So this is unique number. And here we have duplicate and 15, 16 consecutive number. After 14, 15, 16. And this will go 17. And here duplicate. So after 14, 15, 15. So here what will get? 17. So 15, 16, 17. So here after 8, we'll get 9, 9. After that, 10 will get. So similar way, percentile rank also. So wherever we have duplicate values, see here we'll get same percent value. And here also, see here same percent, these three, same percentage. And here also same percentile. And here 4, 6 will get same percentile. Okay, so next we'll see filter duplicate records based on primary key. So here we purely assign the rank based on partition column and based on order by salary column. So here, but in real time, what we'll do, we need to filter the duplicate records based on primary keys. So this is my sample data frame. So if you see here, party A, A1, A2, party B, B1, B2, party C, C. Okay, so this is my data. And these my columns. And by using spark.create data frame, I'm creating this data frame. So now this is my data frame. So if you see in real time, whenever you load data from bronze to silver or any silver to gold or from source to bronze, there will be one timestamp column. So either will be name with the load date or bronze load date or silver load date or gold table load date. So timestamp column will be there. So every day on daily basis, data will be loaded. Suppose today data got loaded and today's date, it will print here. That means today's timestamp, it will print here. So based on this today's timestamp value, we need to find out the duplicate records. So that means every day, whenever moving data from bronze to silver, so every day pipeline will run. So based on pipeline, how you define at a silver level notebook to handle the duplicate records. So it will filter the records for that particular day based on timestamp value. So next what I'm doing, so to define that same function here, Window.partitionBy. So my here I mentioned in partition by product. So that means product is my primary key. So this is my primary key. And on top of that, order by timestamp. So always in real time or in order by will give this timestamp column, either load date or any timestamp column. So now what will happen? So party underscore call. So sample data frame, as we discussed, so this syntax will be same for generating 4 new columns, 4 with columns added here. And if you do display underscore final, you will get this one. So our first result will be this one. So since I given partition by and product, so it will consider only this column, about this column. So here we have party A, 2 times it is repeating. So what will happen? So 1, 2, 1, 2, 1, 2. And here it is 0, 1. and how it will do order by is, one is partition by product, that is one thing. And the next order by is timestamp. So if you see in partition by, this is one group, party A is one group. Since in order by I given this timestamp column, if you see date is same, only varying is a timestamp. So if you see timestamp also different, so here it is 10. So this is first rank, and 11, this is second rank. So why it coming like this 10, 11, and if you see in order by, so how you define whether you mention dot descending or not. Since I'm not mentioned dot descending, by default it will consider in ascending order. That means increase order 10, 11. So this is my first rank, second rank. At the same way, next window is party B. And here also ascending order 9, 12. So this date is same 9, 12. So rank will come same 1, 2, 1, 2, 0, 1. So here we have only one value in this window, party C. So we'll get only rank 1, but here you can see 0% rank. And this is about by using order by. Initially, I explained with all the functions, all the window functions. But in real time, what we'll do, we'll use only row number, row underscore number we'll use. So from this, I selected only this portion. So after defining ranks, so if you consider this one, if you see this part of code, what will get result is up to here. This one column will get add. After adding this, what I'm doing, filter condition. So filter, this column name is equal to 1. So that means I want to filter only the rows where row number equal to 1. So that means wherever 2 is there, so it will get drop. So after doing filter, what I'm doing, I'm using select star party columns. So later I want only these columns. So later I don't want these columns, product, timestamp, all these columns I don't want. So I given select star. So or otherwise, so whenever giving select star particles, actually this is drop is not required because select only it will cover. So what we can do is, I will do uncomment this one, select particles, and I will do drop this one, drop row number. So first I will run this one. And I will run this one. See here. So finally we are getting our input columns. So, but uh, actually speaking, what happens if you don't use a drop? Suppose I will uncomment this drop. So what will happen? It will it will filter the records, but rank column will come here. We'll get rank column here. So 1, 1, 1. But in real time, but we don't require that rank column for further moving tables to gold layer. So what we can do? will do that drop. Rank column will do drop. So what I'll do, I will add here to show the difference. I'll remove here up to here, and this one, this is final drop. This is drop. So here I will activate drop. So now it will be easy to understand. So here column will be there. In next result, you will be having only these columns. Okay. And but in real time, what we had to do is, so here I'm not used this ascending, right? But since we want to retain latest record, and for that, what we need to do is, there is one small change we need to do. So here we need to add the descending here. I'll show the difference here. Why? Because in real time, we need to always keep latest duplicate record. So for that, we need to add the descending here. So if you see now, our result will be same. Result will be different. So order by dot descending. So we need to import this descending. So I will import here first from functions. Windows spec object has no attribute descending. So partition by product order by, should there is small mistake in code, descending within order by, I need to mention descending. Partition by order by, okay, partition by dot order by call dot descending. Similar way we want to write call. I mentioned, okay, I mentioned only this one, only column name. Okay, so now what is the difference is, if you see here, see it giving in ascending order. So that means duplicate record, it mentioning the latest record. So from this, what is the latest record? This one, 11. Why? Because it came at 10 o'clock, it came at 11 o'clock. But what we want to do in real time is, we want to remove older duplicate records. We want to keep always latest latest duplicate record. So if you don't mention here descending, what will happen? Whatever latest records are there, no, it will assign as a duplicate, and latest records will get deleted. Only older duplicate record will retain. So that is the reason in real time, we'll always keep latest duplicate. So here see 11 it come, not 10. At the same time, in this window also, 9 is older, 12 is latest. So in this case, we are getting 9. So that is older duplicate record. But in whenever we define descending, we are getting latest duplicate record, that is 12. Since in party C, we have only one record, so we'll get this one latest. So that is our latest. So always remember, so whenever working in real time, always define order by column. In order by, always define your load date column, and that load date column, you always define descending. So then only your latest duplicate record will be retained. Otherwise, latest duplicate record will get removed. So that's all about this video on how the different functions will work: row underscore number, rank, dense rank, percentile rank, and what is the difference between them, and what is the real-time scenario of how to remove the duplicate records based on primary key. So that's all about this video. If you really like this video, please like and subscribe. Thank you.